Okay, tonight we're going to start talking about Chapter 10. Probably a good idea for you to realize how much class is left. We've got 4 sessions left, two more lectures, a final review and homework lab, and then the final exam. So we're getting close to the end here. And we have finally gotten to the part where we can talk about the real ways in which C++ is an object-oriented language. I mean, we've touched on it in terms of some of the other stuff we've looked at, but we'll finally be making some of our own classes and objects. To lead into that, we're going to talk a little bit about structures. A structure is a data type that actually is a composite or conglomeration of other smaller data types or other component data types, let's say. So it's really a way to associate pieces of data together that are going to be used together. And it kind of predates the class and object concept, but it helps us to get into that mindset. So structure is defined by starting with a struct keyword. We give it a name, and then there's a body in curly braces like we've been using. And that body will list types followed by identifiers. Those identifiers are the member names for that structure. And we put a semicolon right here to end the structure. The reason the syntax calls for a semicolon here is because originally you were allowed to declare a new identifier of this type right here. And in fact, you can do that, but the problem with that is that would make that a global variable, and we don't like those, so we're not going to do that. So just be sure and put a semicolon here to tell the compiler that we finished defining our structure. Once we've defined a structure, we can use it as a data type to declare other variables. So, for example, they've used the CD account type to declare the variable account. Even though that type actually comprises several member variables, we can use it as a single argument to a function that calls for an argument of that type. And the member variables are accessed by using the name of the variable, a dot, and the name of the member variable that we're referring to. On page 546, they show you declaring multiple structure types with member variables of the same name. May be confusing for a programmer, but the compiler knows what's what because he knows the data type of every variable and can therefore determine what kind of a value quantity is based on whether it's a member of crop yield stock structure or the fertilizer stock structure. So this demonstrates using a structure as an argument for a function. We can also use a structure as a value returned for a function. As demonstrated on page 548. The shrink wrap function is declared as being a CD account type function, which means when we get done, we need to return a CD account type value. So this, you can see, is kind of a way to get around the limit of returning only a single value from a function. Although technically we've only returned a single value. That single value has multiple member variables that are part of it. Another thing we can do is use hierarchical structures. Or multi-level structures. So here they've declared a date structure type that has the members month, day, and year. Then a person info structure type, which has members height, weight, and birthday, which is of the date type, which means that birthday is going to have a member month, day, and year. And so if person 1 is a person info type variable, we can refer to person one's member variable birthday, which may also have, and also we can refer to the member variable year of birthday. We can also initialize structures similar to the way that we initialized arrays before by using a list of values in curly braces separated by commas. And like the way it worked in arrays, you can have fewer but not more than the number of members. And the compiler will try or attempt to initialize any values that are not specified with a 0 value for that data type, which may or may not work the way you want it to. So let's look at some self-test exercises. Mr. Gear, number 1, given the structure term account and the variable account, what is the type of each of the following? There's an A, B, C, D, E, F.
Double. That one's not right.
Okay.
Because instead of using the count, they use the name of the structure.
Good.
That one also won't work because it's saving account, which is a different variable than the count.
Okay.
The name of the variable that we said. And that one is a character, and that one's going to be term account. The whole thing.
Okay. Ms. Hernandez, number 2. If we have the definition for shoe type, what would be produced by that code in number 2?
First would be $9.19.
Okay, I think you may have missed a little piece of information in here.
Oh, the A.
Okay, A, and a $sign with 9.99.
The A again. $sign.
Okay, what will be in shoe 2 price? Okay, if it was $9.99 before and we divide by 9, it should be 1.11. Okay, Ms. Hargrove, what is the error in this structure definition in your own words? Number 3.
It's missing the semicolon.
Okay, it's missing the semicolon, which means what do you suppose is going to happen?
I need to reference to something that's not there from like
Okay. It's going to be expecting the name of a structure that we're defining, and it's going to find the word int, which is a keyword, and it's probably going to have some kind of an error like unexpected keyword int or expected, identifier or something strange like that.
but that would not run as a one.
Now, it would not compile. Let's see one more. Mr. Gear, let's look at number 5. Here's an initialization of a structure type. Tell me what happens with each initialization and what problem there might be with those. And they keep having a typo here. B and C are identical, and I think it probably would work better if we made one of them different. So I'm going to change C to be a different one. Tell me what happens.
There's not enough in A.
Okay, so what will happen?
They'll leave here empty.
So what it will actually do is try to put a 0 value in year, and for an integer, it's pretty well defined, so it probably will just make year equal to 0. Which, has the potential for causing problems in code that depends on year being some actual value. B,
There's too many.
so that's too many, so that's going to be a syntax error.
Right.
All right, C, the way I've changed it,
That'll work.
should be okay. And D,
Will also work.
but it'll have the year 22, which if we're using 4-digit years or, we know
Does it say it's you?
that would be a long time ago, year 22. Once upon a time, we made a big deal out of the Y2K problem. Mostly that's dealt with by using larger values that can hold on to the entire year and not have to worry about it. All right, so we've covered structures. Let's talk about classes now. I've already mentioned a couple of times that a class is a data type whose variables are objects. And so objects are kind of like structures in that they can have multiple pieces of data, but they go beyond structures because we can also have code that's part of that entity. So in addition to having pieces of data, we can also have In other words, in addition to member variables, we can also have member functions. And here in display 10.3, we have an example of a class called day of year. And it has a function declaration in addition to 2 variable declarations. And we call a member function kind of the same way we would call any function, except it has the object name that it's a member of in front with a dot. So we have today, which is an object of type day of year, and birthday, which is also an object of type day of year. And we can call the output function on each of those in turn. Something else that we haven't seen before is this public label. A label in C or C++ is an identifier followed by a colon. In this case, it's a special label that indicates that everything after it is public, meaning it can be referenced by code that's not part of that class, that object. So it was somebody's bright idea that an object-oriented program could group all of the data and common functions together and make the object that's being referred to its own thing, encapsulating all of the information and behavior it needed to act as if it was a real-world object. And some people really enjoy working with object-oriented code, and some people not so much. When we declare the class, everything inside the class declaration is going to be private unless we tell it otherwise, which is the opposite of the default behavior for a structure. In a structure, that's going to be public unless we declare it private. So in order to have any part of the information in a class be public, you have to put in the public label. In order to declare or define the function, so we're declaring it here, but to define it, we actually have to declare it with a little bit of extra syntax here, or define it with a little extra syntax. This is a void function that's a member of the day of year class. So we have day of year followed by the scope resolution operator. We've talked about that before. And then the name of the function. this is called the type qualifier, meaning this output function only goes with the day of year class. So you can see that our output function in the case of this day of year class is going to just simply output the month and day of the particular object that it's called with. In this program, that's either going to be today or birthday. So if we call output on today, it's going to output the month and day that are stored in the today object. And if we call birthday.output, it's going to output the month and day that go with the birthday object. Oh, Ms. Hernandez. Page 559, self-test exercise number 11. They've added an input function to the day of year class. Void input, no parameters. How would you define that function?
The seek out,
Okay, so we're defining it. We need to start with the type, the name of the function, that stuff.
void day of year,
Void day of year two colons that are the scope resolution operator.
input,
Okay,
enter curly brace, seek out, and then month as a number. No, as a number. Enter month as a number,
as a member. Okay,
as a number.
oh, as a number. Okay, sorry.
CN, month.
Okay.
Out. Enter the date of the month. The date.
Okay.
And then CN. Day.
Okay, that's it. You notice that we just referred to month and day in here. And the compiler keeps track of what month and day we're talking about because we're in the scope of the day of year by using our scope resolution operator. It's going to be whatever month and day go with the object that we're calling this function for.
So the scope operator means you don't have to use the dot operator inside the function.
Right. All right, let's take a short break and we'll resume in about 5 minutes.